Okay, our study basically involved uh, our, uh, our study involved digital twin with integrated with machine learning for predictive monitoring of carbon emissions for existing buildings. And the purpose of the study was initiated with the realization of the fact that 80% of our currently inhabited houses would still be in existence in use in 2050, which made the retrofitting of existing assets a significant challenge for the industry. Further, if we would, the development of the policies for underpinning the EPC and the SAP ratings, which were identified by the Climate Change Committee, they were driving the retrofitting works for decarbonization. But, however, to assure that the implemented strategies shall perform as required, we need to monitor the past, present, and predict the future. So, for the as-built assets, so that we can deliver the expectations to achieve net zero strategies. And apart from this, there is a rising concern in the industry for energy efficient design strategies, which require increasing the air tightness measures for the building envelope. And that, again, it negatively impacts the quality of the indoor environment. So the entire study was based on how the monitoring of the TVOCs and the ECO2 from the spaces can allow us to implement better retrofitting and ventilation systems for the housing assets. And the different pollutants from the materials and from the indoor quality of air that affect the indoor quality of air are basically from the combustion of gases from fireplaces, then the fumes which would be coming from the garage, including the carbon monoxide emissions, and chemicals and cleaning products, and the particulate matter from CO2, which constitute of the CO2 and other gases from cooking. These all indoor emissions also contribute to the GHG emissions, which are not being encountered for or monitored with respect to digital twins and predicted. And these further impact the sick building syndrome, which it reduces the cognitive abilities and the strategic thinking of the users and occupants. So these are this was the purpose of the entire study, which was based on how we could utilize the live information feeds for designing efficient ventilation and air purification systems, plus enhancing the indoor conditions of spaces while reducing the pollution and reducing the energy consumption based on the behavior by implementing digital twins to achieve the monitoring and the 2050 targets of reduced carbon emissions. Digital twin, as we see the advancement in the industry today, they present an opportunity to plug this gap between the as built and the as designed assets, and by providing an insight into the utilization of space with real time information, which allows us to provide predictive maintenance, condition monitoring, real-time diagnostics, and what-if analysis. And the three main components which drive the digital twin here, they are building information modeling, the BIM, for the ACFM industry, plus the real-time integration of wireless sensor networks, and lastly, it's the data integration and analytics with machine learning algorithms. So this entire system is how we have implemented for this particular study, where we have started with implementing the IoT system components, which included the IoT devices which were installed in the residential unit for transmission of data and for the data storage, followed by modeling of the existing asset in by laser scanning, which would allow us to model the existing assets and convert them into to digital model layers. Then the third aspect was integration of the model and the data itself. That was developed in the Azure Digital Twin platform, where we were able to take the real-time data from the devices which were installed in the spaces and monitor their behavior and based on the alerts and the real-time data systems. And the last layer, which included, was the data analytics layer. So this was the entire digital twin architecture, where the last layer involved prediction of of these ECO2 emissions based on the SGD technique to forecast the future emissions from the spaces. Okay. So this was the IoT system component layer, which was utilized, and where we utilized the microcontroller, which was connected to two sensors, which were capturing the temperature, relative humidity, and one of them was capturing the TVOC and the ECO2 from the spaces. The data transmission and the storage in the cloud, it was connected through the Microsoft Azure platform, and this involved we utilized MQTT, which was the message queuing telemetry transport, a lightweight message protocol, which allowed us to connect this the real-time data into the cloud platform, from where we have from where it was also it was transferred to the real-time information to implement it on the 3D model, as well as it was stored, and then we use the same data for predicting the future emissions. The study was carried out in a small housing unit, which involved a bedroom, a 1 BHK apartment, where the devices were installed in the living room. One was installed in the kitchen, and the other one was installed in the bedroom to capture all this emission data. And The modeling of the asset was carried out by laser scanning, which was then converted into a BIM LOD model of 300 or LOD3, and then it was transformed into the scene studio for capturing or imprinting the real-time information into the model with alerts, and the alerts were classified for if the CO2 levels went high, then the shading of the spaces was changed. The system also involved utilizing the real estate core ontology, which was to replicate the physical asset and its environment as a digital twin graph. And this was used because it is an open source ontology which was based on the industry standards like brick schema, which were allowed for overcoming the interoperability issues for data exchange and storage of information. So it allowed us to use this ontology to form the digital twin graph, which replicated the spaces which were in the physical environment. And the second aspect of the digital twin aspect was the data and model integration, where we have utilized the REST API to ensure the transfer of the information from the physical devices to this digital twin graph, and that allowed us to automate the entire the back end process of the real time information being updated onto the digital twin graph. There were two main aspects for this. That the one main aspect was to model the digital twin environment, and the second was updating the digital twin graph. The last aspect is the data analytics, which involved using the data which was stored in the cloud platform and processing the data and using the feature engineering through one hot encoding, which involved the daytime features to model and train the predictable data, which allowed us to provide the predicted output in a Power BI platform, which predicted the ECO2 emissions from the stored historic data. We use the Python script over here to do the data processing and the feature engineering, which also involved the SGD, that is that's the stochastic gradient descent regressor with L2 regularization. This is a short video where we have shown how the data. Sorry. Yes. So this is how we have captured the data in the platform in IoT Cloud, and it has can just take you through the graph where we have been able to see the data in real-time environment, where the graph was being updated with the live data feeds from the installed devices on site. And furthermore, if we would have and furthermore the data which was also captured on the building information model, which was highlighted in different color codes as the CO2 and the temperature and humidities were getting captured. The yellow indicates that the CO2 levels were high in the bedroom, and the red indicates that the entire residential unit was having a high humidity level of 71%. And this was captured in the BIM information model, which we had developed from the cloud platform, from sorry the point cloud, by laser scanning, which showed this the entire process of the CO2. And then lastly, the real-time dashboard, which this is the real-time CO2 eCO2 emissions, which was shown on the dashboard, and this is the ones which were predicted. So here we were able to see that the although the values were not exactly the same, but what we noticed here is that the emissions were high during the evening, and also the prediction model predicted that there were high emissions in the living room, similar to the actual emissions which were stored in the cloud platform. And lastly, the entire study, we concluded that it would have three significant implications. One is digitalization of the existing assets to monitor the condition in real time. Plus, this would enable the facility managers and occupants to monitor performance of assets. And the major conclusion of the entire thing, of the entire system, is that integration of BIM, IoT, and artificial intelligence in one platform allow us to develop digital twins where we can where it would allow us to realize to realize the net zero buildings, and it would allow for reducing the performance gap between the expected and the actual building. And the lastly, this is a framework, an overall framework of comprehensive integration of technologies and the potentials that enable us to achieve the net zero targets. So the integration of all these technologies and digital twin would allow us to monitor the real time emissions from spaces, predict the CO2 emissions and energy consumption, optimize energy consumption, and also provide us with what if analysis for retrofitting these assets appropriately. Finally, it would also allow us to reuse and recycle these materials. So by using the data, by using um, sorry by using the data assets of material data assets, we can also material audit data, we can also reuse and recycle, which would allow us to implement circular economy principles. So this framework is basically showing how we can implement these digital technologies to realize the net zero targets, which would allow us for reporting these emissions, reducing operational carbon, offsetting the residual carbon emissions based on what we have been monitoring, based on the past, present, and the future predictions, and also realize the circular economy principles for assets. Finally, concluding the study, we realized that the opportunities of digital twin as a subset of the Industry 4.0, comprising of its technological advancements such as BIM, IoT, cloud computing, and artificial intelligence, provides an integrated CPS where cyber physical system for setting net zero targets, monitoring performance, and identifying reduction strategies further, which enable us to ensure zero carbon communities and cities. Thank you for allowing us to present at the Digital Twin Hub, and I hope this information has helped everyone.